Problem number 6. What are domain and range for the function f of x equals to the cube root of x plus 4 minus 2? All right. Let's just graph the function, see what we got. Okay, let's graph the function. We got, we need a cube root, so we need control caret 3 and x plus 4. And let's see what else we need. Oh, minus 2. So let's make sure we come out of that. And then the minus 2. And there's our graph there. All right. Domain and range. If you look at the domain or look at the x-axis, you know, we can't put a wall here because the function keeps on going. We can't put a wall on the right because the function keeps going. So our domain is all real numbers. And same thing, this function never stops going down and it never stops going up. So we can't put a ceiling, we can't put a floor on there. So the domain is all real numbers, which I'm going to indicate that with an R. And I should get to one of those around here somewhere. Where's that R? Going right by it. R, all real numbers. And then my range is also all real numbers. There are no asymptotes. There's nothing that prevents. So that's the domain and range of this function. Okay. To make it easier for you to see how we got the domain and range, I've transferred the x values of this graph to the x-axis, and I'm transferring the y values on this graph to the y-axis. Notice what happens as I trace. As I trace the x values of the graph, it goes through the entire x-axis. So the domain is all real numbers. As I look at the range, it goes, keep in mind that the line does not stop here. But there it goes, if you look at the orange, the range point here, it goes from 1, it continues to go. So if I was able to keep drawing this line, this point will continue to rise. And if I was able to continue all the way to the, if I was able to keep going to the left, this point will continue to go to the left, and this point will continue to go down. So that's why the domain is R and the range is R. Same thing with this graph. Let's say I actually put a point on this function. Menu, geometry, point, on, and I just put a point right here. Let's see, point. Would it let me put, yeah, it'll let me put a point right there. I know why it wouldn't let me put a point there. Okay, I'm going to transfer. Let's see. Let me go ahead and into that. I'm going to transfer. First of all, let's clear that. Let's transfer the x value to the x-axis, and we're going to transfer the y value or the range values to the y-axis and observe what happens. So I'm going to go to menu, geometry, construction, measurement transfer, and I'm going to click this number and put it on this axis. I'm going to click this number and put it on this axis. And just so that you can tell them apart, I'm going to change the color here, blue, and I'm going to change this color to red. All right, looks like I accidentally changed both of them. Let's take this one back to blue. Let's see, there we go. All right, watch what happens as I move through the entire function. So as you can see, this piece right here, the point refuses to go past this to cross over this asymptote. And here, so I cannot trace past the asymptote. So those are, so we got an asymptote, looks like one is at 12, and looks like there's another asymptote at -8. Okay, see if I can get this point over there to jump it there. Now, if I jump, right now I'm tracing fine. And as I go over it again, I run to the same situation there. So I can jump over, and then when I get over here, I can jump over. And so the point that you never see for X, here you'll never see 12. It gets real close. The calculator will start guessing in a minute, but it won't give me 12. Same thing here. I can trace every point on this curve but 12 and -8. I can get close to it, but never exactly. So that tells me what my domain is. So the domain of my function here is from -infinity, -infinity, -infinity to, I believe, what was that? That was 8, -8. Okay. And we also needed -2 or -8 to, I believe it was 12, and then from 12 to infinity, positive infinity. And let's get that positive infinity. All right. And let's also not forget that we need the union of all of these. So this is all together. So let's go ahead and find that union symbol. Around here somewhere, I'll find it. Getting close, close. And then I went right past it. Or did I? Let's see. Okay, I'll pause the video until I find it. Oh no, there it is. Okay, there it is. There's one, and then let's select it again. There. All right. So this represents my domain. So that's the blue point. All right. And with the red point, again, as I trace, trying to grab that, looks like I'm at a point where it's kind of hard for me to get it stuck there. But you see, I was able to trace every point of the graph, but I couldn't quite get 0. I get close to it, but I can't get it. So my range need a text box here. So my range is from -infinity, and I need that -infinity, -infinity to 0, and then 0 to positive infinity. Okay, and I also need that union symbol there, so I'll borrow it from here. And so this represents my range. And this represents my domain.